Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss second method to solve a linear differential equation of second order with variable coefficient. This is very famous method and very interesting method, also important method, which we want to discuss in this lecture. How we can solve a linear differential equation of second order with variable coefficient by the method of normal form. The name of the second method is normal form. Normal form or removal of first derivative. Removal of first derivative. First derivative means dy dx. First derivative remove from our question. Then we get second method, normal form. First method we have already discussed in last lecture. The name of the first method is complementary function known, or one integral known, or we can say one solution known. So method 2 we want to discuss in this lecture. Method 2, the name of the method is normal form or removal of first derivative to solve linear differential equation of second order with variable coefficient. This method is very important method, very interesting method, and very easy also method. So we discuss in detail how we can apply in our differential equation to solve a linear differential equation of second order with variable coefficient. So first of all, I want to discuss about a general type of linear differential equation of second order with variable coefficient. So in first method we have also discussed about the general linear differential equation of second order with variable coefficient. So here type of general linear differential equation of second order with variable coefficient is given as below. Differential equation is same. Methods are changed here. One by one method I am solving a linear differential equation of second order with variable coefficient. So several methods, with the help of several methods, we can solve our question. Different methods we can apply, different module we can apply in our differential equation, and we can find the solution. So our general differential equation, that is d2y d over dx2. We have already discussed about this differential equation in last method. So this is the second order derivative in y, d2y over dx2. One is multiplied before this. If there is any other function before second order derivative, any other function, any other number, then we divide by that function or number to the whole differential equation. Okay. Our general differential equation says that there will be no function before the first term, the second order derivative. So now second term, in second term is first order derivative dy dx, and there is some function multiply with first derivative here in second term. In third term is function is y, and here q is also some function multiply with function y. Y is dependent variable. Here x is independent variable, y is dependent on x. In right hand side there is some function of r. R is the function of x. So basically here we see that here p, q, r are all function of x, and d over dx is capital D. D over dx differentiating with respect to x is represented by capital D. So here is single dependent variable y. and single independent variable x. So this differential equation is known as a ordinary linear differential equation with variable coefficient. Ordinary linear differential equation of second order with variable coefficient. And we want to here apply a method normal form or removal of first derivative to solve the general linear differential equation. So first of all, we want to discuss about the method, about the procedure of the method, how we can apply this method in our question, general equation. After it, we will solve one problem on this method in this lecture. So now, definition of linear differential equation of second order with variable coefficient. One number, I am already telling you, one number multiply with second order derivative of the differential equation. One number multiply with second order derivative of the differential equation in first term. First term, there are three terms in our given differential equation in left hand side and one term in right hand side. So there are third term within three term. First term is second order derivative and one number is multiply in our second order derivative. No any function, no any number multiply with our second order derivative of given general linear differential equation of second order with variable coefficient. Okay, this is the first point, very important point. If there is any number or any function multiply with second order derivative, then we divide by that function or number to whole equation on both sides. And p is a function of x is multiply with first differential coefficient in second term of the given differential equation. And q is also function of x multiply with derivative dependent variable y. And in RHS, r is also some function of x. In right hand side, r is given r, in general equation is given r, and r is the function of x. Here y is also function of x. X is function of x. X is independent variable and r, y is also function of x. So here general differential equation is d2y over dx2 plus p dy dx and plus qy is equal to r. Here p, q, r are function of x. Are function of x. Okay. This is the linear differential equation of second order with variable coefficient. Here p is the variable. Variable means function of x. Q is the variable. Q is the function of x. And r is also function of x. So this is general ordinary linear differential equation of second order with variable coefficient. Here we will discuss about the method how to solve a problem based on general linear differential equation of second order with variable coefficient. This is the general ordinary linear differential equation of second order with variable coefficient. Equation 1 can be solved with the help of the following method. Following method is method 2. Method 1 we have already discussed in last lecture, but now we want to discuss about the method 2. Method 2 is normal form. The name of the method is normal form. Means the given general linear differential equation of second order with variable coefficient change in normal form. After changing normal form, we can solve the equation and we can find the solution of 1. Apply method to normal form. Normal form or removal of first derivative. Removal of first derivative. Removal of first derivative. Removal of first derivative to solve given equation 1. Solution of equation 1, we see that in equation 2. There are two values Equation 2 is this. This is solution y equal to u into v. Y equal to u into v. There are two solutions. We see that in equation 2 there are two values u and v. What u is already known when question is given. In this question also, when we start to solve the question, then we have formula for finding value of u. So we get the value of u at the starting of the question. So y equal to uv, this is the equation 2. We have considered here, considering y equal to uv, this is complete solution of 1. Let us consider this. Y equal to uv, this is equation 2, and equation 2 is the complete solution of equation 1. So here let us consider the solution. But if this is equation 2 is complete solution of 1, then verify to 1. Okay. Now verifying equation 1 with the help of solution 2. Y equal to, here consider that y equal to u into v is the complete solution of 1. Complete solution of equation 1. Okay. Here consider that y equal to uv is the complete solution of equation 1. That is y equal to u into v. This one. This equation 2. This equation 1. General equation 1. This is solution. Considering solution this. Okay. Differentiating this solution verify to 1. If this is complete solution 1, then this verify to 1. Now differentiating 2 with respect to x on both sides. We want to verifying by this solution to the equation 1. So if this is the value of y in equation 2, we have value of y. Putting in here. Again putting value of dy dx. First time differentiating of equation 2. And putting value of d2y over dx2. Again differentiating equation 2. Then that is verifying equation 1. So now differentiating equation 2 with respect to x on both sides. So here u and v are also function of x here. U is also function of x and v is also function of x. So u differentiate with respect to x and v also differentiate with respect to x. So y equal to u into v. Here apply product formula. Product formula. So dy dx after differentiating equation 2, we get dy dx equal to u is constant, first term. First function is taking constant u. Differentiating of second term dv over dx plus second function is constant b. Differentiating of first function du over dx. So here we consider y equal to u into v is the complete solution of given equation 1. If this is complete solution of equation 1, then this solution verify to 1. After verifying, so putting the value of y in our given equation and putting the value of dy dx first order derivative and now putting the value of second differential coefficient. All values putting in equation 1 from the given solution, considering solution. Then our equation is verifying. So first time differentiating we get equation 3. Now again differentiating with respect to x to 3. Then we get here dy dx differentiating with respect to x dy dx of dy dx differentiating with respect to x of dy dx equal to differentiating with respect to x of equation 3. This is equation 3. U dv over dx plus b du over dx. This is equation 4. apply product formula in equation 4, then we get product formula. Product formula means differential of u into v, this equal to u into dv and plus v into du. This formula, this is product formula. We apply here this equation 5, product formula, du into v equal to u dv plus b du. So here we, from equation 4, we see that here differentiating dy dx one time, then we get here d2y over dx2. Second differential coefficient of y with respect to x. And in right hand side, d over dx of u into dv over dx. d over dx of v into du over dx. So there are two terms. Both are in multiply. There are two functions in each term. So we apply the product formula in each term. So here d over dx of u into dv over dx plus d over dx of v into du over dx. This is equation 6. Here product formula apply and here product formula apply. So after differentiating 6, we get this. d2y over dx2 equal to d over dx u dv over dx plus d over dx b du over dx. This equation same as 6 last page. I have taken in last page. This is same equation. Now apply here product formula. U is first function constant, differentiating dv over dx with respect to x, differentiating with respect to x dv over dx plus dv over dx constant, differentiating with respect to x u. So du over dx. Now here differentiating v with respect to x, we get dv over dx and du over dx constant and plus b constant, differentiating with respect to x du over dx. This is equation 7. Now d2y over dx2 equal to u into d2, two time differential of v here. dv over dx already one time differentiating and next differentiating with respect to x, then we get d2v over dx2. Here dv over dx into du over dx plus dv over dx into du over dx plus v, here d2u over dx2. So this is the same term in equation 8. This two term are same. This term and this term both are same. So this is twice. So d2y over dx2 equal to u d2v over dx2 plus twice of dv over dx into du over dx plus b. This is two time differential of u d2u over dx2. This is equation 9. Now putting value from equation 2. Equation 2 means y equal to u into v. This is equation 2. Equation 3. Equation 3 is dy over dx. This is u dv over dx and plus b du over dx. This is equation 3. From equation 2 this, from equation 3 this. And equation 9. 9 is this last equation, this 9. This is 9 equation. This is 9 equation. Okay. So from now putting value from equation 2, equation 3 and equation 9 in equation 1. Then we get here. So here we get here this equation 1. d2y over dx2 plus p dy dx plus qy equal to r. This is general ordinary linear differential equation of second order with variable coefficient. Now we have considered the solution y equal to u into v. And now we are verifying the given equation with the help of considering solution. So considering solution is y equal to u into v. One time differentiating this, we get this equation 3. Again differentiating this, we get equation 9. So 9 we putting here value. First of all from equation 9, the value of d2 by dx2. Here we, so b u d2b over dx2 plus 2 dv over dx and du over dx plus b d2u over dx2. This is the value of second order derivative total. This is from equation 9 and plus p in second term p, value of d by dx. This is d by dx. This is from equation 3 and plus q into y. This is by value of y from equation 2 equal to r. This is equation 10. writing equation 10 in second order differential equation in V. Same order, we are writing here the equation number 10, same order as given equation 1. What is order in given equation 1? Second order derivative, first order derivative and no order derivative. Similarly, we write here the equation 10 in same order in V. Second order derivative of V, first order derivative of V and only B. No order derivative of B. Then we write here, we get here u d2v over dx2, second order derivative of V plus. So in last equation, there is only single term d2v over dx2, this term, single term this. So writing this term, here we see that in next dv over dx here and dv over dx here. This is common. This is common. So dv over dx taking common here. dv over dx is common. So we get here 2 du over dx plus pu plus. Now b is common. In last equation, equation 10 b is here and v is here and v is here. In 3 term b is present. So after we taking common out of 3 term, remaining function we are writing in bracket. Then we get here this b is common. So here d2u over dx2 plus p du over dx plus qu equal to r. This equation 11. Dividing by u to the equation 11 on both sides we get. Why we are dividing here by u? Because in our general given differential equation, there is only one number multiply with second order derivative. What here is second order derivative in first term? Multiply by u. What here must be 1. So we remove u from here. So we dividing whole question by u. Then we get here d2b over dx2 plus. Now here is 2. We get 2 upon u du over dx. Plus here pu divided by u means only p here. Plus here 1 upon u. Here is d2u over dx2 this term. We divide by u 1 upon u d2u over dx2. Plus p by u du over dx plus q. Here is qu in equation 11 qu divided by u only q into v equal to r by u. Right hand side is r. After dividing by u, we get r by u here. This equation 12. After verifying with the help of our considering solution to the given general differential equation 1, then we get final result is equation 12. This is final result. This is second order differential equation in B. Where now let where P1, this is result is P1. P1 equal to P plus 2 by u du over dx. This is equation 13. Next, this is the coefficient of dv over dx. Next coefficient of v is q1. Q1 we are considering this. 1 upon u d2 over dx2 plus p by u du over dx plus q. This is q1. Equation 40. And next is R1. R1 is R by U. This is equation 15. Putting value from equation 13, 14 and 15 in equation 12, then we get equation 12. Then we get this equation d2b over dx2 plus p1 dv over dx plus q1b equal to R1. This equation 16. This is same as equation 1. The equation 16, same equation as 1. Equation 16, same equation as 1. Okay. So equation 16 is known as a linear differential equation of second order with constant coefficient. This equation is constant coefficient. P1 is number, Q1 number, R1 is function. We apply method here by equal to CF plus PI. And we can find value of V. value of v from 16. We can find value of v from 16. Now, this is equation 12. Okay. Equation 12 represented two methods. This break in two methods. Method 1, complementary function known. Method 2, normal form or removal of first derivative Okay. So now in first method we have taken the coefficient of v is equal to 0. Coefficient of v means this result. This is the coefficient of v. If we taking coefficient of v equal to 0, then we apply method 1 or removal of v. We can say removal of v. Here removal of v. But now we want to here apply method 2. Then here taking coefficient of dv over dx. Coefficient of dv over dx is equal to 0. Then we get method 2, normal form. dv over dx means this result is 0. P1 result 0. So here is removal of v. Removal of dv over dx. We want to removal of dv over dx. So putting dv over coefficient of dv over dx is equal to 0. Then we apply method 2, normal form. So now apply method 2, normal form or removal of first derivative. Normal form or removal of first derivative. Removal of first derivative means coefficient of first derivative taking 0. In our equation, last equation 12, coefficient of first derivative is P1. So here we taking, now putting coefficient of dv over dx is equal to 0 or P1 0. We putting here P1. P1 is 0 in our equation 12. In equation 12. In equation 12 putting P1 equal to 0. From equation 13, P1 is 13 given in equation 13. So P1 must be 0 here. It means P plus 2u dv over dx equal to 0. Okay. If putting P1 equal to 0, then method apply 2. That is known as a normal form or removal of first derivative. Removal of first derivative means the coefficient of dv over dx is 0. If coefficient is 0, then that is removed from the question. So here u is known. When we putting P1 equal to 0, then we get a formula of u. With the help of this formula, we can find the value of u. So here P plus 2 upon u du over dx equal to 0 or 2 upon u du over dx equal to minus P. This P taking to this side. Now here apply 2 upon u du over dx equal to minus P. This equation 20. To solve equation 20, apply here variable separate formula. This is the first order and first degree differential equation, and first method in a first order first degree differential equation, that is variable are separate. If in any differential equation variables are separate, then we can solve easily. So in this equation 20, the variables are separate. P is the function of x here. So here is dx, cross multiplying like this. So after cross multiplying, 2 taking this side. So 1 upon u du equal to minus of p dx. So 1 upon u integration 1 upon x dx. This is log x. Formula apply here, this log x. So we get here log u equal to minus 1 upon 2 integration p dx. P is unknown. Integration p dx here. P is unknown here. If P is known, then we can find integral. P is unknown here. So this is same as. Now removing log, log x equal to y. So x equal to e to the power y. This is formula. So we get here u equal to this formula, e to the power minus half integral p dx. This is formula 20 equation. This is formula for finding u. If p is known, then u is known. P is known, then u is known. But p is given in our question. Putting the value of p in this integral in equation 21, then we can find the value of u. Now, from equation 14 we have, 14 is q1. q1 let I, q1 is I. So 1 upon u d2u over dx2 plus p by u du over dx plus q. This is equation 21. This is the coefficient of v. This is the coefficient of v in 12. Of v in 12. Okay. This is the coefficient of v in 12. This result. So putting value of u from equation 22 in 23. We have find the value of u in 22. That is putting in 23. Then we find the value of I. So now I is equal to, putting here 1 upon u. This is u minus half integral p dx. 2 time differential d2 over dx2, putting value of u, e to the power minus half integral p dx, plus p upon u, u, this is u, e to the power minus half integral p dx, dy dx of e to the power minus half integral p dx, plus q. First I am writing here q, I equal to q, plus here 1 time differential, here 2 time differential. So dy dx is out, 1 time differentiation of this function. Now here p upon this u and 1 time differential of this here d over dx, 1 time differential. So differential of 1 time dy dx of e to the power ax means e to the power ax and dy dx of ax. So this is formula apply here. D by dx of e to the power ax. So first time is e to the power ax and dy dx of ax. So e to the power ax into a. This is formula. So same here apply this, minus half p e to the power integral p dx. Now q plus 1 upon e to the power minus half integral p dx, dy dx of minus p by 2 e to the power half integral p dx. So here this result is cancelled to this. So here is minus half p square. This result is minus half p square. Here again apply product formula. P is function and this function and dy dx here. So apply product formula here. So I equal to q plus 1 upon this is u, minus half is common, taking minus half is common, and here d over dx of this p into this. This is u, this is p. Product formula apply here. P is constant, differential of this constant, differential of p. So here apply product formula, minus half in bracket, dp over dx, differential of p here, dp over dx, and this constant plus p, differential of this result. And now minus half dp over dx, this is same, and plus p, and differentiating this one time, minus half p e to the power minus half integral p dx. Okay, so this is common, this result common and cancel to this. Now we get this common and this cancel to this here. We get here minus half dp over dx, multiply minus half dp over dx and plus 1 by 4 p square, minus half p square. So we get this formula. This is I. Very important formula is this. I equal to q minus half dp over dx plus 1 by 4 p square minus half p square. I is equal to q minus half dp over dx minus, after solving this 1 by 4 p square, minus 1 by 2 p square. 4 is LCM, p square minus 2p square. So this is minus 1 by 4 p square. So here minus 1 by 4 p square, this is 26. This is very famous formula for I. I is constant here. Equation, from equation 19 we have, this is S equal to R by U. This is 19 equation, putting value of U here. Then we get value of S. S equal to R upon U, this is U. So value of S equal to R e to the power plus half integral p dx. This is 26. So here we find the value of P1. P1 is 0. Putting value of P1 0, then we find the value of U. U is e to the power minus half integral p dx. This is the value of U. And then value of I. I equal to Q minus 1 by 2 dp over dx and minus 1 by 4 p square. This is value of I. And last is S. S equal to R e to the power plus half integral p dx. This is formula. U, I and S. Only three formula we have find out here. That is value of U, value of I and value of S. So finally putting value of P1, Q1 and R1. Then we get here d2b over dx2. P1 is 0 here. Here P1 is 0. We have already considered. So here this term is removed from our equation. And Q1 is I, then IB equal to R1. This equation 27. So this equation is second order in B. 27 equation. This is known as a normal form. Equation 27 is represented the normal form. B2 normal form this. B2 plus IB is equal to S. This is known as a normal form. After solving equation 27, we can find the value of V. From equation 20, we can find the value of U. 20. What is 20 equation? 20. 20 is this. This is 20. 21. From the equation of 21, this is 21. We can find the value of U. With the help of value U and V, we can find y equal to U into V, complete solution of 1. So this is the procedure to solve a ordinary linear differential equation of second order with variable coefficient with the help of normal form. This is normal form. B2 plus IB is equal to S. This is normal form. U equal to e to the power minus half integral p dx. This is formula for U. P is known here. Putting the value of P in this formula, we can find U. Next, S equal to R by U. R into e to the power half integral p dx. Here R is known, P known. Then we can find S. And I equal to Q minus half dp over dx and minus 1 by 4 p square. This is value of I. PQ are known. So in our question, the value of PQ are always known. P, Q and R are always known in our question. PQ are always known. So with the help of these three formulae, first formula is for U, second formula is for S and third formula is for I. So we can find the value and then we can find this normal form. Normal form B2 plus IB is equal to S. Then we can find the value of V. Now, this is the procedure we have discussed in detail about the formula for normal form. Okay? How we can find the solution y equal to U into V. How we can find the value of U. How we can find the value of V. For finding value of U, we have given here one formula. U equal to e to the power minus half integral p dx. P is known. If question is given, means P is known. After putting the value of P here, then we can find value of U. R is known. Then we can find S with the help of formula S equal to R by U. R is known and U is known. Then S is always known. And PQ are given in our question, then I is also known. I is also known means normal form is known. B2 plus IB is equal to S. So with the help of this equation, second order differential equation in B, we can find the value of V, that is normal form. So this method is known as a normal form. Our given differential equation convert into normal form. Normal form is in B. After solving this equation, we can find the value of B. And complete solution is y equal to U into V. This is the total method, procedure of method to find out the solution. Now, we want to solve here one problem based on this method. Method is normal form. So problem 1 based on method 2, normal form, or second name of this method is removal of first derivative. Removal of first derivative. If we remove of first derivative, then method convert in normal form. So now solve. d2y over dx2 minus dy dx. Here is 4. Here is minus 1. Minus 4 dy dx plus 4x square minus 1 by equal to e to the power x square sin 2x. Okay. This is given question in question paper. We want to solve this question with the help of normal form. How we can apply here normal form method 2? How we can apply here method 2, that is normal form. So this is very simple question, and within 5 minutes we can solve this question with the help of given formulae in last procedure, in last method. So solution, I am writing this question d2y over dx2 minus 4 dy dx and plus 4x square minus 1 by minus 3 to the power x square sin 2x. Sin 2x. This is equation 1. This question is given in our question paper. Means any question given in our question paper, first we see that the highest order derivative is second order derivative in first term. We see that there is only one number multiply here, no other function, no other number here should be. Here should be only single number 1 multiply with second order derivative in first term. So before second order derivative there should be only 1, because our general differential equation is this type. But question is same. This is the differential equation, general differential equation. This is 2. And 2 and 1 both are same. Given question and general differential equation both are same. Then we can compare in 1 and 2. After comparing in equation 1 and 2, then we get value of PQR. When question is given in our question paper, means PQR known. Here PQR known. PQR known. 100%. Now step 1 apply. There are only 3 steps. Within 3 steps we can find solution. Step 1 now, let y equal to u into v solution. This equation 3 is a complete solution of 1. Y equal to u into v is a complete solution of 1. Here we apply following formula for find u, I and s. We find out u, we find out I and s. So now step 2, formula for u. This is formula we have proved in last procedure, in last method. We have discussed here about the method in detail. How we can find the value of u this. We have proved the value of u this. So u is equal to e to the power minus half integral p dx. Putting the value of p here. Then we get value of p. Step 3. This is the value of I. We have already proved this formula. Step 3. S equal to r by u. Okay. Step 1 is considering solution. Step 2, formula for u. Step 3, formula for I. Or step 4, formula for s. Okay. So there are only 4 steps. After apply these 4 steps, we can find the solution. So here is step 1. This is step 1 eating. Step 2. U is this. Putting the value of U here, minus 4x. Integral 4x. Here putting U is equal to e to the power minus half integral p dx. So e to the power minus half integral p minus 4x dx. So here e to the power minus half, here minus 4 into x square y 2. So 2 to 4 minus minus plus. So e to the power x square y 2. X square only, 2 nahi. So this result is e to the power x square, this formula. Now next I equal to q minus half dp over dx minus 1 by 4 p square. Putting value of p and q. So I equal to q is, what is q? Q is 4x square minus 1 minus half d over dx of, this is p. So here is 4x and minus 1 by 4 p square, any 16x square. Okay. So now here I equal to 4x square. I equal to 4x square minus 1. This is correct. 4x square minus 1 minus half d over dx of 4x minus 1 by 4 minus 4x square. 4x square minus 1. So here is 1 minus 1 by 2, here is 4 and minus 1 by 4 16x square. So this is 4x square minus 1 minus minus plus 2 minus 4x square. 4x square is cancelled. So I is 1. Step 3 S. R e to the power plus half integral p dx, putting value of p and r. So r is e to the power minus, here is 3 and sin 2x. E to the power half integral s. This is wrong s. This is correct. Minus 3 e to the power x square sin 2x e to the power half. Here is 4x square. S is equal to, here r means 3 minus 3 e to the power x square and sin 2x and e to the power plus half integral minus 4x dx. So minus 3 e to the power x square and sin 2x and into e to the power plus half minus 4x square by 2. So this is 4. So this is minus 3 e to the power x square and e to the power minus x square. This cancel and here is sin 2x. So this is minus 3 sin 2x. Okay. So this is s. S minus 3 sin 2x. This result sin 2x. So this cancel. This is minus sin 2x. 3. Now normal form is d2b over dx2 plus ib is equal to s. This is 10. Putting value I and s in 10, then we get d2b over dx2 plus ib. I is 1. I is 1 and s is this minus 3 sin 2x plus I1, this 11. Solving equation 11 by CF plus PI method. So now here d square plus 1v equal to minus 3 sin 2x. This equation 12. Putting RHS equal to 0 to find complementary function of 12. If we find the complementary function of equation 12, then we putting RHS 0. So RHS 0 equation is d square plus 1v equal to 0. This equation 13. Putting d equal to m and removing y from the equation 13. Then we get an auxiliary form of 13. So m square plus 1 equal to 0. After solving this 14 equation, we get m equal to plus minus I. Plus minus I. 0 plus minus I. So alpha equal to 0 and beta equal to 1. So formula is CF C1 cos x plus C2 sin x. This is CF. Complete complementary function. Now particular integral 1 upon fd into q. We have discussed this particular integral in last chapter in detail. So 1 upon d square plus 1 minus 3 sin 2x. Putting d square equal to minus a square. A is here 2. So a is here 2 minus 2 square means minus 4. So f minus a square is not equal to 0. Then pi is equal to minus 2 square plus 1 minus 3 sin 2x. So minus 3 sin 2x. So this is particular integral pi, equation 16. B is equal to CF plus PI, complete solution. CF plus PI. CF is this C1 cos x plus C2 sin x. And PI is minus 1 upon 3 sin 2x. Now, complete solution of given problem, that is y equal to u into v. U into v is the complete solution of 1. So, putting the value of u and v, we get complete solution. Y equal to u into v. U is this e to the power minus x square. This is u. E to the power minus x square. What is u? Minus 4. E to the power plus x square. This is plus x square. U is e to the power plus x square. And this is b. b is c1 cos x plus c2 sin x. And here minus 1 upon 3 sin 2x. Okay. So this is complementary function plus particular integral. This is the value of b. Okay. And this is u. So this is complete solution of given problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.